Hello everybody, welcome to our next lecture. In our previous lecture, we discussed the PLC architecture and PLC programming. Especially we discussed the ladder logic programming method, and also we discussed the advantages of ladder logic programming method compared to other programming methods. And also we have seen how the ladder logic programming looks like, and we also discussed the way of designation of the different graphics, graphics means symbols of input, that is buttons, start buttons, stop buttons, timers, and output coils, relays, etc. Of course, it is very difficult to understand the ladder logic programming, by just seeing one or two examples. Okay, that's why we have made this subject as a theory cum practices. So definitely you will be doing the practices on the PLC. Okay, that is you will be getting the exposure on the PLC programming and the configuration of PLC, communication of the PLC with the computer, and as well as the other devices like sensors and actuators. And also we are going to execute the program to operate certain actuators in the practical sessions. Okay, we have all the necessary facilities to develop different PLC programs and to actuate different actuators like hydraulic actuators, pneumatic actuators, and electrical actuators, of course. Um, yeah, we have one separate automation setup which actually includes PLC, HMI, SCADA, and etc. Okay, at the end of this uh, okay semester, okay, at the end of this last part of the subject, definitely will be having the confidence on the uh, the PLC and other types of controllers. Okay, and you can easily understand how the controllers are being used in the industrial automation for various monitoring purpose and controlling purposes. Okay, so next one is a PLC timer and counter. So we have the wristwatch. Actually, it shows the time, and as well as we can if you want to perform certain task within certain perform certain task and measure the time, we have the features, like a stopwatch. Okay, so like that, in PLC also there will be a virtual timer. Okay, so it is the internal clock. Okay, a count value, register and an accumulator, and the timer is mostly useful for timing processes. So many of the control tasks would need the programming of time. The timer instructions are used in PLC to create the program time delays. And so here this is the symbol. Here there will be a start input, output, time delay, and a reset. Okay, this is a symbol of the timer used in the PLC. So start input means once the start input gets the signal from either the start button or from the relays, okay, it will start to count. Okay, so here the delay time is how much time we would like to delay the output, okay, in terms of seconds or microseconds, depending upon the type of the PLCs. Mostly we use the microseconds. Okay, and 1000, if it is going to be the 1000 means it is equal to 1 second. 2000 means 2 seconds delay. So after the start input is get energized, okay, the timer will starts to count, okay, and each and every time for each and every microsecond it will convert, I mean compare the count value with the predefined delay time value, okay, until the counted value become equal to the predefined delay time value, okay, uh, then it will give the output, okay, to operate certain relays or to operate certain solenoid valves and etc. So I understand it is very much difficult for you to okay cope up with this theoretical part of PLC timer, but once you start to work on the PLC programming in laboratory session, you can easily understand. Okay, so just uh, have a basic idea of a timer. So timer in PLC, it's a virtual part of the PLC which is used to delay the okay process for certain amount of time. Okay, so that is a function of timer. Okay, so the number of timers that can use in the program is dependent on the amount of memory in the CPU and as well as the application. Okay, so timers are used in the PLC to delay the actions as we discussed earlier. Timer would keep an output for a specific timer after an input turns off. Okay, the timer would also keep an output off for a specific timer before it turns on. So on delay timer, off delay timer, both are available in the PLC. Okay, so we'll discuss in detail in the practical session. Okay, so timer instructions are nothing but okay, the timer accuracy will be dependent upon the microprocessor which is being used. The timer instruction is composed of two values and they are the accumulated value and the preset value. This is the current accumulated value is nothing but the current number of time based intervals that have been counted from the moment when the timer is energized. Okay, that is counting value, how many seconds, that is accumulated value. Preset value means, so we have to, the programmer has to define, okay, for how long the timer, okay, a delay to produce the output, that is the preset value. Okay, so the timer is composed of two status bit. I think you know what is bit and the difference between bit, byte and etc. Okay, so if you want to okay learn about the bit and bytes, I will share the separate okay links for them in a Google Classroom. Okay, so here the timer enable bit, this bit will be set if the trunk condition to the left of the timer instruction is true, and when this bit is set, then the accumulated values will be incremented on each time base intervals till it reaches the preset value. So what this paragraph trying to explain is as we discussed in the previous slide. So there will be a pre-defined delay value in terms of seconds or microseconds, and once the timer input is energized, it starts to count from 0, okay, until that counting value reaches the predefined value. The output of the timer is in off condition. Okay, if it is on delay timer, then the accumulated value reaches the preset value, then it will start to give the output. If it is off delay timer means the output is energized, the accumulated value will increases and it is compared with the predefined value. Once the accumulated value reaches the counted predefined value, then the timer will cut off its output. Okay, that is the difference between on delay and off delay. So that is what I explained here. So done bit, this bit will be set if the preset value and the accumulated value are equal, and it will be reset if the trunk condition is false. Okay, so after completing one cycle, okay, the accumulated values should be okay reset to the 0. Okay, because while executing the program, okay, multiple times in a cyclic manner, okay, that accumulated value should be in 0. Okay, the accumulated value should be 0. Then it will start to count from 0 to until the predefined value. Okay, if accumulated value is not, okay, resetted, okay, then it will be equal to the predefined, okay, delay value. Okay, so that then there should not be any delay. Okay, so it will directly give the output or directly cut the output. Okay, so every time we have to reset the, okay, the accumulated value. Okay, like we are generally using the, okay, trip meter in the, okay, car. Okay, while going for the, okay, long trip, we generally use the trip meter. The trip meter is used to know how much distance we travel. That is one use, and another use is indirectly it is used for uh, calculating the mileage given by the, okay, vehicle or the car. So after completing a trip, we will reset that trip meter into 0. So in the same way, after one cycle, the completion of one cycle, or during the completion of the function of the each timer, we have to reset the accumulated value. Okay, then only it will be, okay, used for the next cycle with the count from 0 to the predefined value. Okay, so I know it is very difficult for you to understand this once again. So but if you work on the PLC in the lab session, definitely you can easily understand and enjoy the way of programming and use them for the practical applications like controlling the different actuators and etc. Okay, so I already explained the working of the timer and also two types of timer, on delay and off delay. So we need not to, okay, once again discuss these okay, points. Next one is the very important one is the counter. Okay, so timer is the module, one of the virtual module of the PLC used to count the time. Okay, so until the counted value, once I am explaining, okay, for understanding purpose, until the countable values or counted value the reaches the predefined value, either it energizes or de-energizes its output. Okay, here the counter, okay, counters are needed in the PLC to detect numbers and events. Mostly the counter needs to operate with the counters. Okay, so counters are used to eliminate the requirement of relays to represent the events that have occurred, number of times the event. The counters are used to index, increment or decrement the values. So the counter would count from 0 to the predetermined value, and it is a preset value. Okay, as discussed earlier in the timer, here also we have to give the preset value or predefined value. Mostly the counters are used in PLC to count items. An example of the counting the cans which go into the box on the assembly line, like butter filling. Okay, and the counters are really important in the automation of the industrial processes. Okay, uh, yeah, like on delay timer and off delay timer, here also there are two types of counters, a counter up and a counter down. Okay, simply it is called count up, count down. Okay, and yeah, you may aware of the countdown. Okay, while launching the rockets, the scientists may use the, okay, countdown. Okay, at least from 48 hours to 0 for launching the, okay, the missiles. Okay, likewise here count up and count down both are available in the PLC. Depending on the application, either you can use the count up or count down, okay, counters. Okay, so PLC counter is a function block that would count up or down till it reaches a limit, and when the output is set, then the limit is reached. The counters can help to log to SCADA system, supervisory control and data acquisition. They would count the number of times that event has happened, or it would set the alarm when the event happens for a certain amount of time. Okay, so counters consists of variables and it is used to store the numbers in the PLC. So yeah, so counters means if you want to measure or count how many times a particular event happens. For example, if you want to operate a linear actuator, we can count how many times the actuator extended. Okay, extended. Okay, extended and retracted. Okay, complete cycle. Okay, so as a programmer, as a operator, you have to define how many times a particular yeah, actuator should retract or extend or retract. Okay, so here counter is used to count number of times of extension or number of times of the retraction. Okay, to stop the particular process. Okay, so these two numbers, that is, one is predefined value of number of times the events happens, and another one is the counting of number of times events are happening. Okay, so like in timer we use the predetermined value of delay time and the counting time from 0 to until the value of delay time. Like as here also, okay, we need two variables. Okay, one is okay predetermined value, another one is the counting. Okay, so next one is the addressing, PLC addressing. First one is the input output memory addressing. So addressing is very important in PLC because we need to define, okay, uh, what has to be, okay, taken from the memory, what has to be stored to the memory, what has to be taken from the memory to process and give the output, okay, what has to be received from the data acquisition card or the sensors and stored in the okay memory. Okay, so these are the okay some of the uh, mm, functions being happening inside the PLC. So for those functions we need to okay give the address, the way or the locations where the particular data are stored. Okay, so PLC application interact with the external world through the input and output modules and our SCADA systems. Okay, when designing your PLC applications, you decide which variable should be attached to the input output modules, okay, and communication modules by labeling the variable with the PLC address. Okay, OpenPLC runtime uses the IEC. I already told you, International Electrotechnical Commission. IEC means is IEC 61131 nomenclature to address input output memory location. It's the international standard used for okay standardizing the PLC programming. Okay, so the addressing of input output location is done through the use of special character sequences. The sequence of the concatenation of the percentage sign. Okay, percentage sign. Okay, and yeah, for addressing the okay the input like start button, stop button, or sometimes we can make use of the output of the a timer or counter as the input for the next operation or the next cycle. Okay, so for those okay input or output okay modules, we use the prefixes as I, Q or memory. So here I is nothing but the input. Okay, it may be the start button, stop button, or the input okay from the sensors. Okay, Q is for designating the output. Okay, so and M is for the output of the okay either the counter or timer, and it is designated as memory in PLC. Okay, so you can easily understand once you start to do the practical part. Okay, and the following size prefixes are supported. Okay, depending upon uh, the value. As we discussed, we need to define the preset value for the timer and as well as counter, and the counting value for timer and as well as counter, and etc. So depending on the value, okay, we can use X if it is going to be 1 bit, B for 1 byte or 8 bit, W for 2 byte or 16 bits, D for 32 bits, L for 64 bits. Okay, and so we have come to the last part of this module means unit. So advantages of PLC. Okay, we already discussed the advantages and disadvantages. Once again, we will discuss okay advantages. Here some special features are listed here. So the programmable controllers has eliminated much of the hand wiring associated with conventional relay control unit. So as we discussed early in early days, okay, the people used a big electrical panel for automating the industrial processes. Okay, and it is somewhat difficult to understand for the newcomers. Okay, only experienced persons can handle them, and a lot of difficulties will be there. And so to overcome those disadvantages, okay, the PLC has been invented. Okay, so the programming of the PLC is somewhat similar to that a physical type electrical ladders used in the early days, so that even a layman can easily understand them and develop the program for PLC and execute them. And the PLC increases the reliability of the operations compared to the older type relays, physical relays. Okay, and once a program has been written and tested, it can be downloaded to other PLCs. Yeah. Okay, so the cost is comparatively low, and originally PLCs were designed to replace relay control logic, but it is capable of not only relay switching tasks but also other applications such as counting, calculating, comparing, processing of analog signals, and etc. can be performed. So the cost savings using PLC have been significant that relay control. Okay, okay. Uh, I mean something wrong in this, that obsolete. So except for power applications. Okay, and yeah, there are some more advantages. Communication capability. Okay, easy communication capability. PLC can okay communicate with the other controllers or computers or the equipment through okay certain communication protocols, especially the Ethernet. Okay, communication protocols are enough to communicate with other devices. They can be network performed such as supervisory control, data gathering, monitoring device and process parameters and downloading. So faster response time, of course. PLCs operate in a real time, which means that an event taking place in the field will result in operation or output taking place. And easy to troubleshooting, and the PLC have resident diagnostics and override function, allowing a user to easily understand and correct okay, software and hardware problems. Okay, in fact, the simulation of the PLC also, okay, PLC programming also, okay, possible. Okay, so with this, the PLC part is over. Okay, and another important part of this first module is the microcontroller. Mr. A. Kumarasamy, okay, is the expert in that title. That is microcontroller, since his specialization is mechatronics. So I'm seeking his help for explaining the the concepts of microcontroller, that means the architectural features of microcontrollers, okay, operations of microcontrollers, applications of microcontrollers, advantages and disadvantages. So you will explain the the microcontroller through the another video. So thank you all. So once again we'll meet in the next lecture to discuss about the next module or the next unit, which actually deals with the HMI, human machine interface. Thank you.